This video is about logical positivism and what we can learn about it from Suppe's article. The logical positivists were interested in questions about the foundations of science and mathematics that were inspired by developments in mathematics and science in the early 20th century. The two most notable developments that influenced them deeply were first, Einstein's introduction of special relativity in his famous paper titled On the Electrodynamics of Moving Bodies in 1905. Also, the logical positivists were deeply influenced by developments in mathematics and logic, and the singular event there that influenced them deeply was a publication of Russell and Whitehead's Principia Mathematica, in which they developed the system of first-order logic, which basically replaced the kind of logic that logicians had been using since the time of Aristotle. There were other scientific developments and developments in the history of mathematics that influenced them, but these are really the two principal ones. In the early 20th century, in this Germanic movement that we call logical positivism or logical empiricism, there were three main schools of philosophy. There was a certain approach called mechanistic materialism, another called Machian positivism, and then Neo-Kantianism was a view that attempted to revive the views of the famous German philosopher Immanuel Kant and modify them. We could talk about each one of these three movements for quite a while, but I'm going to focus exclusively on Machian positivism. If you have questions about the other ones, feel free to drop me a line. Ernst Mach, who's a famous physicist, philosopher, believed that scientific statements must be empirically verifiable. And as Suppe tells us, he also believed that all empirical statements in a scientific theory must be capable of being reduced to statements about sensation. So this is a very important point that emphasizes Mach's unique kind of empiricism. Not only is it the case that for Mach, any statement in science must be something that you can connect to empirical measurements, but it must be that whatever that measurement says, you can somehow express as a collection of reports about what you are currently sensing. Now, the main problem with developing this kind of Machian positivism is that reports about our sensations are not easy to mathematize. If I report that I'm seeing a little patch of red here, right next to a little patch of black, and then next to another patch of white, and so on, those kinds of reports of sensations are not easy to mathematize. And yet, the empirical descriptions of science that we need are highly mathematical. So early logical positivists agreed with Mach that verifiability is a criterion of meaning in science, by which they meant that statements in science should only be regarded as meaningful if we can specify the specific empirical configurations that would verify that statement. And they also agreed that to some extent, what science is about is phenomenal regularities, by which they mean simply that science tries to describe the patterned experiences of the world that we all have. Our experience of the world, our sensations of the world are not chaotic or quote-unquote random. Our sensations of the world are highly organized and structured. And the subject of science is to try to predict that pattern of structured sensations. These regularities are characterized in science by theoretical terms, but these theoretical terms are terms that describe things that we can put into a mathematical language. So the theoretical terms become conventions that can be explicitly defined using the language that describes phenomena. And here phenomena is being used in a philosophical sense that means roughly what we are currently witnessing in our sensory field. Okay? It is important that for the early logical positivists, the theoretical terms are conventions, because an important part of what the logical positivists were interested in was trying to separate out how much of science is conventional and how much of it is constrained by our empirical findings. So in the original version of the received view of theories, scientific theories should be axiomatized in first-order logic. And that's because first-order logic was understood to be a sort of perfect language in which we could write scientific statements in such a fashion that they could never be misinterpreted. And so there's two things that are going on in this first claim that I've got on the slide here. First, that we're going to try to rewrite the scientific theories that we find in our textbooks in the language of first-order logic. That's one step. But once we've got every statement written out like that, what a logical positivist would want to do is axiomatize that theory. And to axiomatize a theory means to select a small collection of statements as principal or primary, and then to show that the rest of the statements in the scientific discipline are logical consequence of that small collection of statements that we call axioms. The terms in the scientific theory, once we rewrite it in this pristine language in first-order logic, are going to be divided into logical or mathematical terms, theoretical terms, and observation terms. So every single word, if you want to think of it that way, in our rewrite of science is going to fall into one of these three categories, and it must fall into exactly one of these three categories. So if we take a word like energy, it's either going to be a theoretical term, an observation term, or a logical or mathematical term. And in that case, it probably would be a theoretical term. If we take a term like electron, it's going to be either an observation term, a theoretical term, or a logical or mathematical term. And in that case, it's also going to be a theoretical term. As opposed to, suppose we're talking about a chemical solution that changes color after a certain amount of time, and we say the solution changed to, turned yellow after 35 seconds. The phrase, the solution turned yellow, is going to be an observation term or a collection of observation terms, because those terms denote things that we can witness with our senses directly. So the axioms of a theory, once you rewrite it and axiomatize it, are called the laws of the theory. And they specify the relationships between the theoretical terms. And the theoretical terms, as we already said, are abbreviations for phenomenal descriptions, whose meaning is given by correspondence rules. And correspondence rules are sort of like dictionary entries that pair up theoretical terms on one side and statements containing only theoretical terms with statements containing observation terms. And so for logical positivists, these correspondence rules were absolutely crucial as a way of filling the theoretical terms with meaning. What a theoretical term means is exhaustively given by a correspondence rule, and therefore what the theoretical term means is exhaustively given by how it is connected to empirical evidence. So logical empiricists were famous for rejecting metaphysics. It is a consequence of the original version of the received view, because if you take a metaphysical term, such as the term entelechy or a term like soul, those terms are not observation terms. You can't see someone's soul. And so, according to the logical positivists, since they're not observation terms and they're not terms in mathematics or logic, they have to be theoretical terms. But a term like soul doesn't have a correspondence rule where we can connect it up to an empirical procedure for measuring it. So if it's a theoretical term, it's going to be a meaningless theoretical term because it doesn't have an explicit definition through a correspondence rule. And if the term soul is a meaningless term, it literally means nothing, there's no point in using it in our discourse. And so any attempt to get into a philosophical debate, for instance, about whether or not our soul continues to exist after we die, is really just idle talk about meaningless words. All of this is, of course, a direct consequence of the verificationist theory of meaning, which says that the only meaningful discourse is discourse that's done either in terms of phenomenal language or using terms which are abbreviations for expressions in phenomenal language. Okay, so this is what Suppe is telling us, and he's doing a good job of describing what the logical positivists believe. Any assertions that fail to meet these conditions, Suppe tells us, were metaphysical nonsense. Okay, so the logical positivists were kind of strident in the early days in their rejection of metaphysics. And again, on a charitable interpretation of what they were trying to do, they rejected metaphysics because they felt that it had a lot of potential for misleading people into thinking that what they were gaining was wisdom, when in fact it was simply a bunch of meaningless talk. A debate arose in the early days of logical positivism concerning what exactly observation terms refer to. And on one side, there were the phenomenalists who believed that observational language was supposed to be a description of sense data. This is a very radical view that really couldn't sustain critical assessment, because what it suggested was that if we were going to reduce science to a phenomenal description of this sort, where the observational language is describing sense data, then instead of making a simple statement in our reconstruction of our scientific language that said something like, the pointer on the dial pointed to 0, what we would have to do is give that description, that observational description that said the dial on the pointer pointed to 0, in terms of sense data. Now, sense data are really abstract things, but they're supposed to be sort of the smallest chunk of sensation that we witness. And so if we were going to give a description of what the dial was doing when it was pointing to 0, we would have to describe every little chunk of sense data in that observation, almost as if we were describing this picture that you see here on the screen, pixel by pixel. Well, that's insane. Nobody thought that you could ever take the statements in science and reduce them that far, so that even a statement as simple as the pointer on the dial pointed to 0 has to become some very long, complex description of sense data. So instead, the other camp of early logical positivists said, no, that's ridiculous. Let's just say that the observation language in our scientific theories is going to be a thing language that describes mid-sized objects and their properties, so that the observation statements in our scientific theories can include statements such as the pointer pointed to 0. And we don't have to reduce that any further and describe it in terms of the fine-grained details of our visual field. So physicalism won the day, and logical positivists basically all thought that when we write or rewrite our scientific theories, we should do it in such a way that the observation statements use physicalist language. So as this developed and gained acceptance in especially, again, German and English speaking countries in the early 20th century, the received view of theories that developed looked like this. First, a scientific theory T is supposed to be something that we can rewrite in a very sanitized way as a collection of statements which are divided into two categories. There's the axioms of the theory, which are the laws of the theory, and all of its logical consequences. And, this idea of axiomatizing a scientific theory is something that is done routinely in mathematics as an effort to make it really clear what the logical relationships are among the statements contained within a theory. And even in science, you can do a search and look, for example, for an axiomatic version of your favorite scientific theory. You can look for a version of axiomatic quantum mechanics, or a certain axiomatic version of population biology or something. And the point of axiomatizing theories is simply that it allows us to say, okay, we can treat the small collection of statements as fundamental or foundational, and everything else is simply a logical consequence of these 3 or 5 or 7 things, okay? So in itself, the idea of taking a scientific theory and axiomatizing was it was a good idea, right? It was let's make sure that whenever we propose a scientific theory, we can do this to it. We can rewrite it in this way, even if it wasn't written this way originally by the scientist who proposed it. Let's make sure that it can be rewritten in this way, because then we'll show that it's a logically rigorous, consistent package that contains no internal contradictions. And checking for the absence of contradictions and checking for consistency is a lot easier if you have your theory rewritten axiomatically. Okay? So the job of the philosophers from the point of view of logical positivists is not to do science, but to help in clarifying our understanding of science by rewriting scientific theories in these axiomatic ways. The second part of the review of theories was that when we rewrite a scientific theory, it's going to be written in the language of first-order logic, and the terms in this theory are going to belong to one of those three categories of terms. They're either going to be logical words or observational words or theoretical words. And they were fairly serious about this, logical positivists. It's almost as if you were reading a scientific text, you should be able to go through it with three different colored highlighters and highlight all the logical words in one color, maybe green, all the observational words in another color, yellow, and all the theoretical words in another color, maybe pink. Okay, so that when you rewrite it, it's really clear that any bit of language in science falls into one of these three categories. The terms in the observational vocabulary refer to mid-sized physical objects and their properties because physicalism won out. And there's a set of theoretical statements whose only non-logical terms are from the theoretical vocabulary, and those are the axioms or the laws of the theory. And finally, these theoretical terms, as we've already seen in the early version, are given an explicit definition in terms of observation terms by correspondence rules, which, as I said earlier, are sort of like dictionary entries that tell you what is the meaning of this theoretical statement. So I want to end here by just giving you an example of a correspondence rule to think about so that you can see one, because what is contained in the article by Suppe is, I think, rather cryptic. So here's an example of what a correspondence rule might look like for a logical positivist. And these examples, of course, are easiest to generate when you think about theories that talk about some kind of hidden entity or subvisible reality that is being used to explain what we witness with our senses. So here we are considering, say, early atomic theory that might contain a theoretical statement such as an alpha particle is in this region of space-time. And if we ask, well, what does that mean? What does it mean to say that there's an alpha particle here in this region of space-time? Well, for a logical positivist, what that statement means is exhaustively given by an observation statement that corresponds to it. And so we say, look, an alpha particle is in this region of space-time if and only if a straight track is visible on the photographic plate, such as is displayed in the picture here. So if you look at the observation statement and you look at the words that appear in there, the terms that appear in there, all of the terms that appear in the observation statement are observation terms because they designate or refer to things that we can witness. But on the other side, if you look at the theoretical statement, all of the terms that appear in there are theoretical terms. Okay, now, of course, there's words like is and stuff like that. Those are ultimately going to be words that become logical words. But if you look at the non-logical words, alpha particle, space-time, those are all theoretical terms. But on the other side, on the observation statement side, you have all observation terms like straight track and photographic plate. And so this is an example of a correspondence rule because it shows you how a logical positivist tried to understand and characterize how theoretical statements get their meaning by making them correspond to statements that describe observations. So I hope this helps you make a little bit more headway into the readings by Suppe so that you can really appreciate the subtleties of logical positivism.